Hello and welcome everybody to our special course about groundbreaking concepts of the present and the future of entertainment lighting controls. My name is Daniel and I work for the MA Lighting International Tech Support. Today we want to talk about some requirements and some challenges in lighting control systems and about some solutions a lighting software can offer regarding color control, fixture selection and many more things. So let's have a look at the agenda, what we are talking about. First of all, we want to have a look at the challenges for lighting control systems, and we will see why we need some proper and innovative solutions in some examples. We especially have a look at the color control, which is maybe one of the most complex tasks when we talk about dealing with fixtures and different fixture types and matching the color. So we have the same red, for example. We will take care of the fixture selection, which is the basis of our programming. At the end, we will also have a look at some solutions where we take care of selections which are not always symmetrical. And we have a look at our programming, so especially the live editing of values and timings, which can provide us a faster and easier workflow we've ever had before. And then we will have a look at the game changer of our programming. We want to keep our intended look and we want to use recipes to create this look again. We will have a look at the GmbH 3 software and the concept of recipes which enabled us to do this. Last but not least, we will have a look at some training and support possibilities we as MA Lighting offer. But first of all, let's have a look at the challenges for our lighting control systems. One of the first challenges is a moving light. We have a simple moving light and of course we can describe this moving light very good. We can describe it by the DMX channels normally, and maybe we start with a dimmer on the first channel, the second channel has a shutter and we have a pan and a tilt for a movement, and of course we have a kind of color control. So we have a red, we have a channel for green, and we have a channel for blue and all the following channels for the different functions of our simple moving light. So this moving light can be easily described by putting the DMX channels underneath and starting with the dimmer up to all the other functionalities. What about a more complex fixture, like an LED bar, for example? Of course, we can describe an LED bar with the DMX channels as well. Or at least we can try to do this. So the first channel is maybe a dimmer as well. And we have a color control. So we have a red, we have the green, and we have the blue. So for an RGB color mixing. But now let's think of LED bars where we have the single pixel control. So we can control every pixel of the LED bar individually in the color. Of course, then we have again a channel for red, and again a channel for green, and of course again a channel for blue. And we do not only have 2 pixels, but we have 3 pixels, and we go on with the red and green and blue again. So you can see we come to kind of borders when we want to describe these fixture types just because of the DMX channels, because we have 10, 20 times a red or 10 and 20 times a green for the different single pixels. There are even more complex fixtures, like this one for example. This is an Eye and an Alien Pix, and this fixture has many levels of sub-fixtures. So we have a fixture 1, which is maybe our main fixture, which is the basis. We can control the complete head with a pan movement. Then we have an area where we can do the tilt movement with the head. And we know that we can control all the different single pixels in the head as well. And the single pixels can do a tilt movement on their own. So we come to a structure where we have to describe the geometry of the fixture. So with the different levels we can control. That's one of the solutions we will see in our groundbreaking concepts for the lighting control. So we have to describe the fixture based on its geometry, not only on its DMX channels. So the first challenge for our lighting control system is the complexity of fixtures. And we have to find solutions that our control of fixtures is as easy as before, but matching the rising complexity of the different devices. Let's have another look at the color control, for example. You know that we can have an LED bar, and the LED bar can have a color mixing of red, green and blue. So far so good. We have 3 different color attributes, and this is quite easy to control. So we can get a nice overview in our lighting control system. We only have 3 color attributes, and of course we can mix these 3 color attributes to our intended color. But what if the LED bar is not only providing red, green and blue, but some more LEDs like a warm white, a royal blue, a cyan, an amber or a cold white, so a 7 or a 9 or a 13 LED color mixing. Of course you can see that the color mixing with the different color attributes is getting more and more complex, and of course you will lose some overview in your system, because you do not only have 3 different color attributes, but you have 7, 9 or 13 different color attributes. So the next challenge to take care of the different color attributes is a real-world color control. We will see some solutions later on. Next, let's have a look at the picture. And what can we see in this picture is that we have a rig. And this rig is not symmetrical. There are different areas in this rig, and we have different lights at different positions. But it's not a very simple rig with truss 1, truss 2 and truss 3. All of these trusses straight in a row, but this is very asymmetrical rig with different positions and different fixtures on different places. But of course we want to use these asymmetrical rigs to program some synchronous things or some synchronous movements, some synchronous dimmer effects. And of course then we have to find solutions for an easy fixture selection in these asymmetrical situations. So the next challenge is clever selection tools. We need clever selection tools so that we can cope with the different positions of fixtures and the asymmetrical rigs, for example. And what is even more important in those times is a fast and easy live programming. So we want to have tools which makes it fast and easy to adjust our values in our lighting control system, and these values should appear in real time on our selection, which gives us our intended look immediately. And of course, last but not least, maybe one of the biggest challenges for lighting control system is the preparation time for our show. So the times on stages and the time to pre-program our show is getting less and less. And therefore, of course, we need some tools which enable us to work faster, easier and more intuitive. Let's come back to the color control. We talked about the color control and we know that this is one of the most complex tasks. Let's have a look at the CIE color space. In this color space we can describe a color by using an X and a Y coordinate. And together with the brightness parameter we have 3 attributes to describe this color. For example, this red you can see here. And of course, when we think of using 2 or 3 color attributes, this is a lot easier than to use 7, 8 or 10 color emitters from the different LEDs for our color control. But one massive advantage is that we can match the color correctly to the different fixture types we use in our show. In the background you can see my colleague René, who's turning on some fixtures and turning them to white, and you can see that normally the white is totally different for these fixtures. We can get exactly the same color for all the different fixture types. You can see in this red, for example. The red is exactly the same. We use the color emitter information of the different fixture types, and we use our color engine to recalculate the color. So we could use the different spaces in our color picker with the CIE model, for example, tap somewhere and the color attributes will be recalculated correctly, depending on the color emitter information on the fixture type. You can see the different colors are matching exactly. In the fixture type, this information is in the physical descriptions and in the color emitters. And we can see we get the exact colors with the different emitter informations here. This is the result when you measure the lights and we can see that there is a spectrum for a specific light, and this spectrum with the respective values will be described in the fixture type as well, so in the physical descriptions, using the X, Y and the brightness parameter from the CIE color system. You can get this description as well from the GDTF fixture type directly. GDTF as the new standard of describing fixtures. Next to the color control, we have a look at the fixture selection, which is the basis of our programming. You remember the example with the asymmetrical rig and the tree structure we have for the different fixture types because they are described of their geometry. You can see that we use this tree structure as the basis for our fixture sheet as well. So we describe the fixtures by the geometry, and exactly the same structure we can see in our fixture type. This enables us to simply control the fixtures and control the attributes where they are placed exactly. Let's have a look at a short example where we just select some of these alien pix fixtures, and we know that the single pixels can do a tilt movement on their own. So we can use the tree structure, we can control the main dimmer, for example, then we can go down to the level of single pixels, and we can control the position of the single pixels in the tilt axis. The tree structure in the software will take care that we always control the attribute where it is placed. So even when we control the color now, then we can make sure that we control the attribute where it is placed directly, using the color picker, for example, to adjust the color for the single pixels. So we make use of the tree structure and the physical description of the fixtures directly. Next to the selection of these different fixtures, we also want to have a look at our fixture selection order. When we select some fixtures, normally we know that we can select them just in a row. So fixture 1 through 10, for example. That's what we would normally do. And our fixture selection in this case is very one-dimensional. So we select fixture 1 through 18, for example, and they are placed from the left to the right in a row. We can bring them to full, and when we have a look at a color, for example, and we make a nice color alignment, and when we have a look at the color, for example, and we make a nice color alignment, then we know that this color is aligned from the left to the right. So we bring the color from red in a flow to blue, for example, or magenta, and we can see that the color is aligned from the left to the right because of our fixture selection order. But what if the fixture selection order can not only be one-dimensional, but more-dimensional? We call this concept selection grid, and the selection grid information is stored in a group. So we can call a group which has a two-dimensional fixture selection. You can see it in our selection grid. We have an X and a Y position, and we can make use of this grid as well. It could have a Z position as well, so it could be three-dimensional. What is it good for? Let's make this color alignment again. So we open up the color picker again. We start at red, and we move our color up to blue, for example. You can see that now this color alignment is directly aligned throughout the selection grid, so from the left to the right. And especially the gaps in between are very important, because you can imagine everything we program now is respected with those gaps. And we can make use of our real 3D positions, for example, to use it directly in the selection grid. How is this selection grid built? We could work directly in the grid window and place some fixtures in the X, Y and Z positions where we need them. But of course there is some faster way to do this. We can make use of our 3D positions as well. So if we want to have a selection which is the same as our real world rig, we could use the 3D, draw a lasso, and you can see you get your selection grid immediately and can start programming with this. Let's have a look at another example where we can make use of it. So we use our group again, where we place the fixtures in a grid, and we want to program a synchronous dimmer effect from the left to the right. So we start with dimmer 100, go to 0, and we set a phase from 0 through 360 degrees. You can see again everything we programmed is mapped directly to the selection grid. And especially have a look again at those gaps. So the gaps are always respected. We do not have to take care of the trusses on their own and give individual fade or delay times. We just align a face through the selection grid and the work is done. But this is not only relevant for color and dimmer, of course, but we can use it for positions or movements as well. So we take the grid again, and this time we want to create a tilt movement. So we define 2 points in our phaser editor. This is the way where we program our dynamic movements, our effects in GmbH 3. Again, we set a phase, and we will see that the phase is aligned throughout the selection grid as well. Especially again, the gaps are respected, so everything we programmed is matched directly to the selection grid. This is the way how we can use a 3-dimensional fixture selection, especially when we have some trusses with not the same numbers of fixtures on it or some asymmetrical rigs to program some very synchronous things from the left to the right. This will save a lot of time when we deal with a more complex rig than just 1, 2 or 3 trusses in a row. The next thing is the live editing of values and timings, which is very important. Of course, we want to have a way where we can live edit some values, give some timings in the fastest possible way. Let's have a look at the GmbH 3 software, what is implemented here. Here we work with a window which is called MA Tricks. And the MA Tricks are a real wizard for everything we do in the programmer. Just a simple example. We take our fixtures again, and we have a look at a color. And in our color picker, we turn the color to blue. Now we want to adjust this blue with an individual timing, and we can directly do this in the Matrix window. So we just need to tap in the delay time, and we give a delay from 0 through 3 seconds, for example, and you can see this is immediately done in the programmer. So a real nice situation to adjust a delay timing live on stage. We can combine this with wings of 2, so with a combination of a different fixture selection order. And you can see all these values are active, and we could store it in a preset or in a queue, so there is no simpler way to do this. Next to the delay timing, we could also adjust the fade time, of course. And we set a fade time not only with the programmer to type in a direct fade value, but we can use a slide control directly in the window. It's all about live editing of timings and values in a fast and easy and of course intuitive way. You can see everything is done directly in the programmer. Some more things where we can adjust our values and timings are the invert options we have with the Matrix. The Matrix are not only a tool to adjust some timings, some values and to combine different fixture selections, but we can also invert some parts. Let's have a look when we invert in Y direction. And you remember this is especially relevant when we talk about a more dimensional selection grid. Now when we invert in Y direction, so every second truss is inverted, we move the position, so the tilt for example, and the fixtures are moving inverted in the tilt. So every second truss moves to the opposite tilt direction. So you can see that within one window there are just some simple tools to make the live editing and adjustment of values very fast and easy. But it's not only about the live editing of values, it's also about creating values. Let's have a look at this example where we just have 2 fixtures. And we start with a red, and the second fixture gets a blue. And we store this as a color preset. But before we do this, we have a look at the selection grid. The fixtures are placed there, and we add something which is called magic in the GmbH 3 software. We will see in the minute where we can use this magic. So we add the magic, and we store a color preset. Now we take a different fixture selection. And you know we could store our fixture selection in a group, and this group can contain the selection grid information. So this is 2-dimensional, for example. And now we just call this magic preset we created a minute before again. What you can see is that we can start on red, we end up on blue, and in between we do a real interpolation of values. So a real color alignment from red to blue. This is of course also a nice tool we can use directly on different fixture selections. You can see here an example where we do this for some LED pixels, define some more points and have a look at the magic preset. We take a color alignment starting from red via yellow to blue, back to yellow and back to red. This is another example where we can use these magic presets, but this is also relevant for dimmer, positions, for all the different attributes we could imagine. The next one we talk about is a real game changer in lighting show programming. Imagine a tour and you created some nice looks, some alignments, some running effects, maybe some individual timings for your whole setup. But now at the new venue, the lighting setup changes. And of course, we all know the workflow of getting the new fixtures in there, adjusting the presets, adjusting the alignments and individual timings. In the GmbH 3 software, we now have a solution that does this automatically for you, the recipes. So let's have a look at the new workflow using recipes to store your intended look of your show. What we can see here is a simple cue stack. And this cue stack consists of some different looks, and we used some groups and some presets to create this cue stack. But these cues are not stored regularly, but they are stored with recipes. A recipe contains a fixture selection, can contain a preset or some different fixture selection orders, some alignments, some fade and delay times. So all the ingredients you use to create your look. And you can see that these looks are programmed with just one single truss. But what if our fixture setup changes and we get some new fixtures to our show now? Let's clone some fixtures directly in the patch. This is also one functionality you can find in the GmbH 3. When we copy and paste some fixtures directly in our patch, the data, so everything we programmed, is cloned immediately for these fixtures, so the whole show. So this is a very simple and fast way to clone some data for some new fixtures coming into our show. What we need then when we have the fixtures in our show is, of course, adjusting our group. Because the grid is not only consisting of one truss now, but we have some more fixtures in our grid. So we place them in the selection grid, we have a look that our group is stored, and we use this group in our recipes. So you remember, where we defined our ingredients, we also said that we want to use a specific group. Now this group is changed, and what we can do is simply use one command to adjust the whole show for our new setup of fixtures. We simply use the cook command. When we use the cook command, so we recook all the ingredients we used in our recipes, then for all the different sequences, all the cues where we decide to do this, these ingredients will be recooked to the new ingredients. And one new ingredient is our new group, for example. So we recook everything to our adjusted group. We merge everything, and all the different timings, all the individual fade and delays, all the alignments will be adjusted automatically. And our new fixture setup is working with our intended look. So we really stored the ingredients of our intended look, and with just one command we can adjust our whole show to the new fixture setup. You can imagine that this is a real massive feature, especially for touring, where the fixture setup changes regularly. But there are many more places where we can use the recipes as well. We can use the recipes in presets in our programmer to adjust all of these things for different ingredients. So when we change groups, when we change presets, when we change some different fade and delay timings as well. The recipes take care that everything is adjusted with just one command. Next to the hard facts of all our devices, the network and the GmbH 3 system, let's talk about our training and support possibilities we offer. As the German manufacturer and the development, we are always there for you and support you when you have issues with your system. So let's have a look what we can do for you. MA Lighting is a German manufacturer, but next to the research, development, the construction, we offer some training and support possibilities. Let's start with the MA University. In the MA University you can find the right training course for your MA product in your area. Together with our local distributors, we offer some hands-on trainings, which have the same content all over the world. And with our MA expert trainers, we offer these hands-on trainings in your local area. But next to the hands-on trainings, you can also participate in our e-learning system. On the e-learning, you can find a lot of online courses regarding the GmbH 3 software or some other MA products. And of course, this can be a nice addition to a hands-on training or a training if you cannot attend a hands-on training because of time or travel issues. Next to the trainings and online courses, there are some more video tutorials with some tips and tricks around the GmbH 3 software. Please have a look at this one, maybe they can be really helpful for you. And of course, we offer some online manuals where you can get detailed information on how to use your MA product in the best way. These online manuals are constantly updated, so you can be sure that you find the right information at the right time. In our community, you can share your knowledge and get help from other MA users. So please visit the MA forum, where you can meet other users, share your experience and get some help regarding some technical questions or some workflow issues you have. Furthermore, there is the MA fixture share, where you can find the right fixture type for your fixture. Of course, you know the problem that sometimes your fixture has a different software version and your fixture type does not match the DMX footprint in your console. Then please have a look at the fixture share and you will find the correct fixture type you need for your show. And of course, last but not least, when you have issues or problems on your production or in pre-programming, you can get in touch with us. You can contact us for any questions about your MA product regarding the sales side or of course the technical side in our MA tech support. Therefore again, we are working with our MA distributors in your local area. But of course, you can reach out to us directly for our worldwide MA tech support as well. And we offer a 24/7 hotline. So at any time when you have issues on your productions, you can directly call us and we are happy to help you with your problems. Today we talked about some challenges and requirements in our lighting control systems and about some solutions we can already find in our GmbH 3 software. I hope this was helpful for you. If you want to get more information about this, please get in contact with your local MA distributor or us directly via help@malighting.com. Thank you very much for your attention.